This is the story of the year 2006, when prominent scientists from all over the world detected a poisonous gas in our atmosphere, methane gas. It was noticed that the amount of methane in the atmosphere had suddenly increased significantly, and was still rising. Methane is a type of natural gas which, when released into the atmosphere, warms the Earth's surface just like how, in winters, we use blankets to keep ourselves warm. Similarly, this gas acts like a blanket around the Earth. The heat inside stays trapped, causing the ground to warm even more. Methane gas is more effective at trapping heat than normal carbon dioxide. In 2006, when the sudden rise in methane was observed, scientists initially assumed it was due to pollution caused by human activities, but what they discovered during the investigation surprised everyone. It turned out to be a deep secret the Earth had been hiding. How did this methane gas come into existence? Why is its quantity constantly increasing? How does the scientific community detect methane gas? And most importantly, is this methane a sign of the end of the world, or an indication of a major climate shift? But the scientific community already knew that spikes in methane levels usually occur once every 100,000 years. This information is obtained through deep drilling in icy regions like Antarctica and Greenland, extracting what is called an ice core. Let's assume that 1 meter of snow falls in Antarctica each year. Air from the atmosphere gets trapped in the ice, and the next year a new layer forms on top of it. Over time, layer upon layer accumulates. When scientists extract these ice cores by deep drilling, they act like a time machine, holding a record of the Earth's atmosphere from thousands of years ago. By studying these layers, scientists can determine which gases were present in the atmosphere, in which century, and in what quantities. Using this method, scientists discovered that, in Earth's history, methane levels rise sharply, approximately every 100,000 years. This is a signal that the Ice Age is ending and the Earth is about to start warming again. When an ice age begins to end, within just 20 to 30 years, massive ice sheets start melting and Earth's climate begins to resemble modern-day weather. But here's the issue. The last time such methane levels were recorded was 12,000 years ago, right before the last ice age ended. So why is methane rising so rapidly again? Is the Earth heading for a major transformation, or are we facing a new kind of danger? To understand this, we need to explore the history of the Earth. We are currently in a period known as the Quaternary Period, which began around 2.5 million years ago and continues to this day. This period has two main epochs. One, the Pleistocene epoch, started about 2.5 million years ago and lasted until 12,000 years ago, characterized by repeated ice ages, where large portions of Earth were covered in ice. After thousands of years, the ice would melt, and much of the land would dry up. The cycle of freezing and thawing continued multiple times. During this time, humans evolved, and large animals like mammoths became extinct. 2. The Holocene epoch began around 12,000 years ago and continues to this day. Ice receded significantly, and the Earth's climate stabilized and warmed. Humans learned agriculture and began forming settlements near water bodies, thanks to the melting glaciers that created freshwater resources. Now here's a confusing but important point. Even though we are living in the Holocene, a warm period, we are technically still in an ice age. That's because there is still ice at the poles. The glaciers are just not as extensive as they were at the peak of the ice age. Only when there is no polar ice at all can we declare that the ice age has truly ended. But the key question remains. What causes the Earth to warm up and bring the Ice Age to an end? The scientific community has discovered three major factors, known as the Milankovitch cycles, which explain long-term climate changes. 1. Eccentricity refers to the shape of Earth's orbit around the Sun. While it is mostly circular, it occasionally becomes slightly oval elliptical. When the orbit is more oval, Earth receives more heat at certain points. This cycle lasts about 100,000 years, changing from circular to elliptical and back again. 2. Axial tilt obliquity. Earth rotates at a tilt of about 23.5, but this tilt shifts over time. The angle can range between 22.1 and 24.5 over a 41,000-year cycle. When the tilt increases, polar regions receive more sunlight in summer, causing ice to melt faster. 3. Precession refers to the wobble in Earth's rotation like a spinning top. This affects the timing of seasons and varies over 19,000 to 23,000 years. It influences how much sunlight each hemisphere receives during different parts of the year. These three natural cycles, eccentricity, axial tilt, and precession, together explain why ice ages come and go. However, today's rapid climate changes and methane spikes are happening much faster than any natural cycle would predict.